2 million years ago, survival was violent and intimate. If you wanted to extract marrow from a dense animal femur, you had to hit it directly with a heavy, sharp-edged rock. In the technology tree of human warfare, this is the baseline. Crafting an Acheulean hand axe required specific, intentional engineering. The maker had to deliberately chip both sides of the stone to create a symmetrical, teardrop shape with sharp, bifacial cutting edges. For decades, researchers assumed the early hominins using these stones were strictly scavengers, creeping in to crack open leftover bones only after larger carnivores had eaten their fill. The mechanical flaw of a blunt force hand tool is proximity. Striking a living target means standing within arm's reach of something heavily muscled and equipped with claws or fangs. To survive in an environment filled with apex predators, early humans had to invent a way to put physical distance between themselves and their targets. 500,000 years ago, a hominin wrapped a sharp stone with animal sinew and glued it to a wooden shaft using coarse plant resin, a chemical and mechanical process called hafting. This produced a composite weapon, the Cathu Pan spear tip. Mentally combining two completely different materials, wood and stone, to create a unified third object requires a cognitive leap in working memory. Instead of relying on sheer blunt trauma, hunters could now inflict deep puncture wounds, triggering massive internal bleeding and bringing down animals much larger than themselves. Fast forward to 300,000 years ago. Deep in a lignite coal mine in Schöningen, Germany, excavators uncovered a cache of perfectly preserved wooden spears. This map of the excavation site shows a dense cluster of blue artifacts in the center. Those artifacts map out a massive, highly coordinated horse butchery site, proving these weapons were used in systematic hunts. The Schöningen craftsmen meticulously carved these shafts so the center of gravity was shifted specifically to the front third of the spear. That weight distribution mirrors modern Olympic javelins, granting the weapon aerodynamic stability and a lethal 20-meter range. The engineers behind these precise ballistics were likely Neanderthals or Homo heidelbergensis. Selecting the right slow-growing spruce, carving it for optimal aerodynamics, and executing an ambush on a herd of wild horses requires future planning, division of labor, and a sophisticated level of communication. Over time, that lethal distance expanded. By 71,000 years ago, hunters at Sibidu Cave were gluing tiny stone blades to thin wooden shafts, engineering arrows for silent, long-range kills. But the ultimate expression of prehistoric projectile physics is the Oblazowa boomerang, discovered in Poland and dated to 40,000 years ago. It wasn't carved from wood. The ancient makers sourced their material from the dense, heavy tusks of the woolly mammoth. The ivory was carved into a specialized airfoil that prioritized a straight, high-velocity flight path, delivering an instant knockout at a distance. Mastering high-speed projectiles like this neutralized the physical risk of hunting. Humans could now deal fatal blows while remaining entirely out of reach. In the span of a few million years, human technology evolved from slamming a heavy rock into a bone to launching aerodynamic ivory through the air. These physical artifacts are the outward evidence of a rapidly expanding mental bandwidth. This lethal technology created an evolutionary feedback loop. The precision required for toolmaking stimulated neural growth, while the resulting high-protein meat fueled the massive metabolic cost of a larger, hungrier brain. Ultimately, the weapons engineered for survival became the primary architects of human